The rise of the machines was once a thing of fiction, as ominous robots took over the human race. Today, life imitates art at a rate that many of us are unaware of, but most of us will soon experience. So what is the future for our connected world?
The power impact of machine to machine is actually quite substantial, even though the data may be quite small.
Anything that can benefit from being connected will be. And almost everything that's connecting can compute, and everything that computes is becoming connected.
A revolution is underway. Machine to machine and the connected Internet of Things will soon automate and connect nearly every device on the planet, making our world as we know it a thing of the past. But will all of those devices overwhelm the network?
Machine to machine is at the opposite of the spectrum. It's more of a death by 1,000 cuts.
This type of change, sea change, is not comfortable. And, you have to be up for the challenge.
That is really what's driving the Internet of Things, right? This need and drive to connect to devices.
It's not enough just to offer connectivity.
We live in historic times through innovative technology, but are connected devices providing real value? And how do we translate that value into our lives, our companies, our network? How do we stay connected without draining vital resources? Are we moving towards efficiency and sustainability? Or are we weakening the network? A connected world is what we strive for. It changes the world we live in every day, every minute, and sometimes every second. It's what makes our lives better. It's the future of the network. Almost everything you can imagine in our modern world has one thing in common: a microprocessor, a computer chip. These chips make things faster, better, more efficient. But something has changed. Now our machines talk to each other and learn from one another, creating a systematic intelligence that will reshape the industry, the network, and very likely, our entire world. So why is a connected world still on the periphery of so many minds? Are we going to drown in a tidal wave of connected devices and drain our already scarce network resources? Is the network ready?
The problem is not so much the technical side, can we handle the traffic on the network? It's the business side of, can we make that traffic profitable for the companies that roll out the network? So really the concern there is making sure that the services that are offered by the service provider are generating revenue for them that allows them to upgrade their networks appropriately.
You have to be pretty removed from the world today to not understand what connected assets bring to you. Whether it's connected cars and the services that they provide to you, whether it's all the new devices that people have, whether it's just understanding that this is available and that your competitors are doing this and they're offering new services. Or they're saving more money because they're doing things more efficiently.
It's a phenomenon that's occurring across industries, across the world. So it's not a question of, can I stay out of this trend? It's a question of figuring out how best to apply that trend to your particular business.
The connection of millions of disparate devices will give us incredible amounts of data and value, but also pose clear challenges as industry and consumers demand infinitely more from the network.
The industry is trying to understand how to connect these devices together in a way that's secure and scalable, and in a way that allows the different devices to interoperate. And this is a problem statement that the industry at large has never really had to deal with before.
What we find these days are companies aren't looking to make huge capital investments. They want to get into something and they want OpEx that matches their revenues.
The key challenge is understanding these edge devices that we have, whether they be sensors or smartphones, etc., and looking at from the device level all the way to the business application level, what needs to be done. So you have the devices, the software stacks, the technologies that the solutions are being developed on, and then getting back to the business application, the business solution, and that value proposition and that value chain that has to be addressed in order to realize the features and functions that have to be developed for that business case.
It is a business advantage. It can be made to create value. These connections can be made to create value. And people are going to demand that technology goes quick and maybe even faster to realize that value.
M2M technologies, as we know them, were machines in a one-to-one connection with a central hub, sending data back for analysis. But the rollout of all IP architectures transformed these connections into a system of connected things that records, analyzes, and translates big data into meaningful information, creating value that we have yet to fully realize. So are M2M and IoT interchangeable terms, or is IoT a mere extension of M2M?
I think the original concept of M2M was probably a little bit more of an engineering term from some people that came out with this early on. It was also something that was often run across private networks, private wireless banded networks. And today, with the prolific availability of wireless technology and access, almost anything can be connected. But I think it's integrating more of the common use cases of IoT, and that's both ends of the network. That's going to be the source of data side into the application space, from the things to the space, which I think was maybe the traditional M2M side, to now out into the presentation layer, which addresses things like bring your own device.
It's easy for companies to try out new services, to experiment with new services, and that's really at the root of what's driving M2M and M2M into IoT.
So I think of M2M and sort of IoT the way ILS addresses this is getting information into the environment. And I see sort of the challenges around BYOD and the consumerization of IT is sort of from the application layer out to the consumer of the environment. So kind of M2M might be the on-ramp, and the whole dialogue around BYOD and others is really kind of more the off-ramp of IT to the user community.
So what's keeping us from adopting M2M and IoT?
As an industry, it's been highly regulated for all the right reasons. The opportunity for greater endorsement of standards and open platforms enables opportunity to occur, such that the network can be built in a way that's more scalable and more efficient, and be done in a more rapid way.
There has to be a combination of input from verticals, but with a base of a framework base. I think what you need is a strong standard that reflects the reality, and it's a common denominator for multiple verticals.
When companies are interested in that, in doing an M2M project, they look internally first and try to build it all themselves. It's equivalent to like if you and I wanted to have a cell phone conversation, us going out and first building our own cell phone towers.
If we cannot have enough bandwidth to actually provision these millions or billions of devices, that's going to be a challenge for everybody. But really the problem starts before that. If the cost of the connection, the data service plans that the enterprise or the customer has to pay is prohibitive, where they have to pay so much, for example, to connect the device that it's not worth connecting anymore, nobody wins.
We are living history as a revolution of innovation driven by big data. M2M and connected things is upon us. But how far have we come from just a decade ago?
10 years ago, and maybe even before that, the network was, if you like, the foundation for how we communicated. Designed primarily for voice, providing mostly point-to-point communication capability. Clearly, most of the economy was built on its ability to leverage that infrastructure as a form of communication between buildings, between businesses, between consumers.
I think the market will continue to shake out what's a viable product and offering. Availability, I think by definition, is changing. Not that we want things less available, but the technologies that are present today to make that availability very acceptable are very different than they were 25 years ago.
Clearly, over the years, as technology has improved, the cost of communications, the cost of device, the cost of computing power, if you will, now we see truly a proliferation of devices into many different spaces. Rather than being focused maybe in high-end, CapEx-focused markets like manufacturing automation, semiconductor production, now the ability to go in and instrument activities, processes which in the past would have simply been cost prohibitive. Now it's very important, and it's allowing our customers and their clients as well to benefit from additional data, better control, and really better management of what they're offering.
Every technology is born from a tipping point, a time when change is necessary to boost our systems, our businesses, and our goals. M2M will spike in growth over the next few years, but what caused the sudden deluge of investment in M2M services, devices, and equipment?
These legacy networks that were managed and often private, very expensive to maintain, started to be overrun by the affordability and the availability of wireless broadband. That's probably the biggest thing. Kind of the bandwidth economics became affordable and available for people.
M2M and IoT technologies allow them to move from a standalone product to a higher value or a more intelligent product. And it's a phenomenon that's occurring across industries, across the world.
But as you provide this connectivity options to customers and they see the efficiency gains they can get from them, there's a drive to connect. And that is really what's driving the Internet of Things, right? This need and drive to connect devices.
So awareness and affordability and availability, I think, are the key things that really have changed to make this the tipping point a reality. And everybody now is focused on connecting stuff.
M2M technology is upon us, and very soon we may wonder how we functioned without connected devices. Smart buildings is one integration of connected technologies that the industry and academia collaborate on like never before.
You cannot have an operationally sustainable building without smart building or intelligent building technology. There's just so much data coming from the equipment that's installed in the building, so to operate it intelligently, you certainly need smart building technology.
Florida Atlantic University's College of Engineering and Computer Science is home to one of the most sustainable smart buildings in the nation. This may be the future of smart building technology.
So we're what we call a living lab. The building is both an experiment and a place that we work at. And it's very important for us to collect the data. We've been doing so for about 2 years now since the building opened, so that we could use the measurements that we have gathered for students to do analysis, both for research and practical reasons. And this includes things like our network utilization, room temperatures, water flow, air temperature, all sort of metrics that you would see behind the scenes in a building, but which we've exposed via some data gathering software. The data center is actually downstairs on our first floor. It's part of our living lab, so the front of the data center is actually glass, and we even have mirrors so that students looking in could see the technology that's powering our cloud. When you walk into the data center, you'll actually see 2 rows of computing racks, and they're all enclosed. There's actually a hot aisle which keeps all of the heat that's generated centralized. We actually take that heat and we use it to heat the hot water for the building. And then we have our actual cloud, which are a set of blade computers, and we run a bunch of virtual computers which allow us to provide virtual desktops. One of the problems we face is efficient use of disk space. Oftentimes we see that people have space that they don't use, and others who need space that they don't have. And so by centralizing all of our storage, we can piecemeal storage to those who need it and be very efficient in our utilization. The mechanical room is actually very similar to our server room. We use color coding, and a lot of the tubes are color coded based on their function. In addition, we also have measurement tools in there, and we gather a lot of statistics on the mechanical systems. Those measurements are actually taken back and saved on our servers and will be utilized by students for measurements.
Suddenly you can control every aspect of a building intelligently. And that's the real value for the building owner, because now you get energy usage in such a granular form on an outlet by outlet basis, if you care to, that becomes a powerful tool to go back to your utility and come up with a better utility rate, because you know exactly what your usage is going to be. You'll know when monitors are left on at night and can turn them off automatically. So the potential is huge.
Smart buildings are a good beginning to a sustainability program, but finding real value in green will require a true understanding of the impact of sustainable technologies.
It's been estimated that the impact that ICT can have on other industries is 7-fold its own carbon emissions. So while the ICT industry is consuming a significant amount of energy and contributing to the carbon emissions, and in an increasing fashion, the potential impact that ICT can have on other industries is much, much larger.
If green technology, like smart buildings, improves your business, then why is it not at the forefront of the industry?
Up to now, actually, the focus of vendors and operators and all of the stakeholders in ICT was speed, bandwidth. It's what you and I need as an end user. We want the fastest speed and we want the biggest videos to go through the pipes, right? And energy efficiency was somewhat at the bottom of that list. So we need to put it back to the front of the list.
Greening ICT is a challenge on many fronts, but the industry may not realize one of the real causes of growing energy consumption.
The forefront is spectrum, is capacity, is cost, etc. But when you start to peel these things back, one of the underlying issues comes back again and again to green. So take machine to machine, for example. We think about it as, oh, it's going to add more in terms of the data explosion and whatnot. And that is true. But the other essential element of machine to machine is the fact that it's asynchronous. There's billions of devices that constantly connect to the network. And these sessions make it very complicated for the network to go to sleep, to power off certain parts. And so the power impact of machine to machine is actually quite substantial, even though the data may be quite small. You just have billions of sessions.
Sustainability is a necessary factor for industry to keep pace with innovation. But when did this green effort start and why?
Think about it like a decade ago, where we tried to continue to increase the capacity of wireless systems, and we did that by simply expanding the bandwidth and expanding the bandwidth. At some point we reached a limit, and at some point we reached the spectral efficiency limits of that bandwidth, and at that point the discussion shifted from bandwidth and more efficiency on the spectrum side to other things, small cells, data aggregation and whatnot. The same thing is happening here in green. Right now it's behind the scenes as people are thinking about the technology in terms of other performance elements, but as soon as that goes away within the next couple of years, green will sit there as one of the fundamental elements. And we're ahead of the curve. So eventually it'll become more and more relevant and more recognized inside the industry as one of the key enablers going forward for us.
The network depends on green efforts to maintain capacity and efficiency. The future depends on it.
If you look at the wireless network, for example, which is one of the key drivers for that exponential traffic growth that we see, especially from the mobile video perspective, one of the things we're looking at in the mobile network is really looking at small cell network architectures, where we shrink the distance between the base station, the tower, and the end user and the device, so that instead of the wireless signal having to propagate over a mile or so, really shrink that distance by deploying a lot more small cells, a lot more equipment, but smaller footprint. And that's one of the fundamental changes from an energy perspective, that it will provide the capacity that we need for the future applications, but it will also really improve the energy efficiency.
Whether we are ready for the effects of M2M is no longer the question. A connected world is upon us, and we have to brace for impact.
You know, what are all the things that are going to happen? Are we going to look like the Jetsons in 5 years? No, I don't think so. But we are going to move closer to having things connected and smarter. And as we do that, what are the new cool things?
We can see going forward, particularly by the year 2020, we've reached the spectrum capacity limits. Gasoline and fuel and the expense of electricity is only going up. All of the trends are against us. All of the trends lead to the importance of green going forward.
So there's quite a few things that could be bumps in the road, but I think the advantages to many of these solutions will far outweigh some of the limitations and the impediments, and we'll figure out how to get around them with technology and innovation.
Connecting billions of devices that interact with each other and billions of people will come at a cost of energy, time, and sacrifice. This begs the question, are innovation and consumption too high and wide for the network? Or will the drive of industry keep us ahead of the wave? Stay tuned for part 2 of TIA's Future of the Network documentary titled Broadband Capacity. Are we ready? Coming to TIA2013.org on May 15th.